here. And what it has come back with is the account lookup result, which is at the moment Justin Trudeau. Now, the other thing I've been telling everyone to do is to, this is a simulator, and it's based off some static response rules. So if you go to the 6060 and you go to the static response rules, you will see the rules that it's using to give you those responses. And it might make sense in your POC demonstration to customize that to make a better POC. And in fact, you're going to have to do that because what's installed by default has the wrong currency. So, for example, the get party lookup that I've just called, this is the fixed response rule, and we can edit that and then change the names. But let me change one that's more relevant. So if we go to the sync response rules, and I go to the initiate transfer, I've updated these to have the right currency, but 10 Ugandan shillings doesn't make any sense. So let me update those amounts. I can come in here and change that to 10,000 Ugandan shillings. 10,000 Ugandan shillings, and save that. And then if we go back to the monitoring screen and to the sender and run through the transfers again, then in the initiate call, we'll find that my response has now got the correct values coming back. So your application is going to make these calls, and then it's going to get that response back. What I'm saying is that we can use these synchronized response rules to customize that response to make it relevant to your demonstration. So the minimum that you need to do to get this integration to work is to make sure you call those 3 REST API calls, and then customize the response so that you get a relevant response to your demonstration and your integration. If you need access to the API documentation, you go to the API management at the bottom on the left, and you click on the third-party SDK output, and you go to the documentation. The first one here is a health check, but if you go to the third-party request, these are the 3 calls that need to be made for transfer. So there's your lookup party request, and there are some examples here as well. So if you prefer, you can use the API documentation to configure your code to make those REST API calls. Is everyone happy with it? Could you follow along what I was doing? I'm happy to come around and help you get through that if you're not getting through this phase. It's really important today that you're able to run this so that you can include it into your demonstration. Okay. Okay. So next, there's 2 aspects that I would like to cover today. This is supposed to be a technical session, so please feel free to ask questions as we go along, and that is why it is a bit more technical. Uh, a lot of you guys asked me on the first couple of days about Loop because we're deploying a simulator here. We're not deploying a full version of Loop. So if you're interested in deploying a full version of Loop, how could you go about it? Or you want to scale it up a bit more? I've put I'm going to get Charlotte to share this presentation with you guys. I've put in some links and some guides to help you through it. So I just want to show you that it's here. I'm not going to dwell too much on it in the talk. There are 3 types of people who need access to Loop. The first one is the product owner. So this is tends the product owners are still fairly technical inside Loop. They deal with the APIs and the sequence of the APIs and what is sent in the API and what is that contract, but they don't often get involved in writing code. So we have a whole lot of people, sort of product owner type roles inside the community. A lot of people using that role. I guess I'm one of them. What we offer to those product owners is a view into exploring the API, so understanding the API. And the reason why that's important is because product owners think of product solutions that they want to build, and they want to know, can I use Loop to do that? You know, it's a good question. I want to do it to do this. Will Loop do it? And the details in the API, you know, can I send that information through? What sort of response am I going to get? What are the different flows? So there is, so we often use the testing toolkit, and we got a payment manager on premise to help integrate. The payment manager on premise deployment is specifically to help people build integrations. So I guess that's less product ownery, or maybe it is, to build integrations into Loop as a DFSP. So it's not PASP focused at all at the moment, but this hackathon sandbox is probably a better view into the PASP. But as a DFSP, these links are appropriate. If you're a developer and you're wanting to run a Loop and maybe make a contribution into a Loop, so you want to run parts of Loop in the background, there are a couple of ways of doing that. The first one is using the testing harness. So our testing harness is a Docker Compose version of Loop. So Loop's designed to run on Kubernetes, but as all of you guys see, you can just run the Docker images on a single machine using Docker Compose as well. And it's often simpler and easier to configure and easier to interact if you're not familiar with Kubernetes. If you're familiar with Kubernetes and you want to run it on your own machine, then you can use Loop. We've got a link here to Loop. Loop's a great way of deploying Loop with all the Docker images in place, and then working with Kubernetes. So if you're familiar with Docker Compose and not Kubernetes, use the testing harness. If you want to learn more about Kubernetes, then use Loop. What I haven't put here is Helm. So if you want to deploy it into, let's say, a Kubernetes environment that you've set up locally on a machine, then you don't need a tool. We've got Helm. And now our releases are on Helm. You can just deploy that Helm directly into that Kubernetes environment and then configure it how you need it. Okay, then if you're scaling up and you want to add in security, so adding in security is a big step. There's a lot more that has to happen. You've got to have gateways set up. You've got to have the security being checked and validated. So we've got a different set of tools for that. So unfortunately, Mojaloop is complicated, so that's why there's lots of different ways of interacting with it, depending on what you're trying to get out of that interaction. So we've got something called infrastructure as code, which is based off Terraform, and designed to be loaded into GitLab. So GitLab is a GitOps approach to hosting a deployment environment. What GitOps is it uses Git. So it uses the control system and the history and so the same way that we treat our code, you can have those same controls in place to update your environment. So it's really nice for a productionized environment to be aligned with Git. So you have full traceability of anything that changed on your environment and full repeatability. So you can rerun that same Git environment on a new environment, or you can stand it down and put it up again. So the idea is what's represented in your repository is a reflection of what's running in your environment. And the reason why this becomes important is half of the complexity of Mojaloop is around how you configure your environment. So half of it's the application, and the other half is the environment. So don't underestimate. It's about configuration and setup, and all your security is around how well you do your environment as well. So having a repeatable way of deploying and executing an environment, a productionized environment, is key. And so we use IAC and GitOps to doing that. At the moment, there are various flavors of the IAC. Currently, by default, it runs on Amazon Cloud Services, but there's no reason why it's always going to be Amazon. We do have guys currently working on creating an on-premise version of it, and also a managed services provider that could run on other clouds as well. So there's a lot of work in the community. I've got a new mic. Thank you. Okay, so any questions about the environments and Mojaloop? I think it was a wise choice to just use the simulator for the hackathon because it's really quite a lot of effort to stand up those environments, and I want you guys working on your solutions, not worried about trying to run Mojaloop. So that's why we chose the simulator. But then after this hackathon, if you want to take it further and you want to understand more about how to connect to, those links are going to be useful. So are you guys ready for the technical deep dive into PISP? Yeah, I'm seeing some nodding of heads. So we use sequence diagrams all the time in Mojaloop to sort of describe how to do that. So if you're not familiar with a sequence diagram, the way it works is we have the different parties or the different microservices or the different people listed at the top, and we have a line drawing down their involvement. And then the way to read it is from the top to the bottom. So at the top, those are the actions that happened in the beginning, and then as we go lower down, those actions happen later. We have these blurbs where we can add in some more detailed information about the information that's been passed through. So this is not a technical, detailed one. It's fairly technical, but it's designed to help describe it. So we don't have, for instance, the error cases mapped here. We just got the happy path flow, and the data that I'm showing on the side here is the data that's relevant to help the discussion and the understanding about how this flow works. So, so what have we got at the top here? What are the players? We've got a payer. We've got the third party. That's the PISP, and that's your guys' software. So I've combined it slightly, so we don't have just your payer, the API call that you guys are calling. We've got the output of that from that SDK, third-party SDK scheme adapter API calls. So when you're making that get parties lookup call, in fact, the output of that is our get parties FSP IOP call. So I've just represented it from that point of view. And then we've got the payer DFSP, that is the account institution in which you've linked to. So that might be Airtel or MTM, mobile money. And it's from that account that we're going to be making the payment. Then we've got Mojaloop, that's a central service, and also running inside Mojaloop we've got authentication service that's sitting centrally. Using that service is optional based on how the configuration is done, and also then how those challenges and signing those challenges, sort of doing the PISP authentication, is managed through that centralized service. And then on the right side, we've got our payee FSP, which is the institution that's going to be receiving the money and then distributing that money out. So we initiate a payment from your software. So there's an action that happens, and then suddenly we need to initiate the payment. Then we need to do the get parties call. So the way that flow works is the get parties call goes to Mojaloop. In fact, what I'm missing from here is Mojaloop then consults an Oracle, works out which institution that you're talking to, so it looks up the pay FSP, and then forwards on your call, the get parties call, through to the pay DFSP. And on this side, you then look up the accounts, get that account information, and then return with a put parties callback. So we get a put parties callback, and that has got that account information in. So that mock response that we got with the Justin Trudeau, that really originally comes from the payer DFSP on let's say Airtel or whichever DFSP that we connected to. And then that put parties callback is forwarded on back to the third party FSP, which is you guys, and then you get that message. So that synchronous response that we're giving you, so these are asynchronous calls. So let me tell you a little bit details on the sequence diagram. If it, in fact, I haven't followed protocol, so I'm going to skip it. Okay. So these calls are asynchronous calls. So you make the call, you get a response saying, I will get back to you. I haven't represented it here, but the HTTP call comes back with a 202 saying, yes, I've received your message. And then it responds later on with a put call back saying, here's the information that you asked for. What we do in the SDK scheme adapter, in your sync response rules, is we tie those two messages together and we give you one synchronous response back into your backend API. So, that's why we use the SDK scheme adapters. Just makes that integration into your system so much easier. So the next phase is the agreement phase. So this is where you set up that agreement Well, it's agreement phase, but it starts off with the initiation of your transfer. So the initiation of a transfer is really, it's all this information that we got here, which is the DFSP's account, the type of transfer that you want to do. You want to send the money or receive that total. Gives you the total amount, and then you initiate that. So this information then gets passed through. It goes through to merge loop, and from merge loop back to the payer DFSP. So this is the organization that you've got that trust relationship established from the account linking. And it then receives this request to transfer the money. So the first thing it does is it looks up that consent to see if you've in fact got that trust relationship established, and it validates it, saying, yes, I have a relationship with my sender payer, and it's all in good standing, and I'm allowed to process this transfer. It then generates a transaction ID, and then initiates, well, it returns that back to you saying, to the PSP, saying, I've received this, I acknowledge your request to send this transfer. Then generates a quote ID and initiates a merge loop quote phase. This is the quote phase, really the agreement, so it sets up the agreement. So it sends this message to merge loop, who then forwards it on to the payer FSP, and the payer FSP then looks it up, checks that your accounts are valid, and then calculates the fees, and then returns the result through merge loop back to the payer FSP. So whenever you see this pass straight through merge loop, the reason why nothing is being changed inside merge loop is because the message is staying exactly the same, and it's done that so that we can do that JWS validation and make sure that we are in fact talking to the end participant that we're claiming to talk to. So now you come back with a quote. So the DFSP, the payer DFSP sending the money, has got that quote. It then generates a challenge. So normally the recommendation for generating that challenge is it takes information from the transfer, so who's it going to and the amount and who it came from, and then it encrypts it with their private key. And that challenge ends up being really a long string of nonsense, but it's very specifically related to your transfer. So it's going to be changing every time during that transfer. It then returns that challenge back to the PISP. So in your response back here, you've done the discovery, so you know who it is, and then you've now got the quotes, and you know that transfer can proceed. So you got the fees and the total. So in that call that we, this is the return of the initiated transfer call that we've got in the synchronous response. So this is the information that's back in your system, and now you can ask the payer to proceed with that transfer. And then if the payer accepts those terms and signs the challenge, and if it's a FIDO authorization, it would be a fingerprint. If it's a one-time PIN, then you would be typing in that one-time PIN that you got from the payer DFSP. So you give authorization to proceed with that transfer. That authorization then responds with a put authorizations. So the payer DFSP, if you follow this flow here, the payer actually is asking the PSP for authorization for this. So it initiates it with a post authorization, you get the response back, and then you respond with a put authorization. by giving your signed challenge and the message that you are happy to proceed with the transfer. So that put authorization is then received. So the signed challenge gets received. The payer DFSP, the person initiating that payment, gets the signed challenge. So now they can check that that is in fact a valid challenge and that you've met the challenge. And there's two ways that that can happen. It can happen centrally inside Loop, inside the switch. So if you've configured the switch to use the centralized authorization system, and the one that's come standard with Loop is FIDO, so check your biometrics, etc. Then it would forward that message through to the centralized server, and they would validate that you've met the credentials. And then it would come back with a true or false. Or the other option is you don't have it hosted centrally in Loop, and then the DFSP itself needs to do that validation. So most banks and institutions have a way of validating that that is the end user, that there is a one client, and that would basically, so it's not modeled as part of Loop, it's out what we call out of band. You would do that validation, the DFSP would do its own validation to check that that is that is in fact the end user. Then at this point, we have validated the request, and we built that trust relationship up between the payer. So in other words, there's a three-way trust relationship that is built in the PASP. We've got the payer, the client initiating the transfer, and we've checked that it is in fact that person. We've also validated the PASP. So we validated that it is the FinTech that we set up and configured that trust relationship with, and then the DFSP, who's going to initiate the payer, has also been validated. So all the parties are happy with the other parties in the chain. Because this trust relationship has been now established through validation of their signed consent, because to get the signed consent, we had to involve the payer and the PISP, and we had to have that trust relationship initiated and set up through the account linking, and we've now got the signed challenge through all those people. It means that we are now happy that we are dealing with all the parties concerned. So we now can proceed with the transfer. So the way we proceed with the transfer is we generate a transfer ID, and then we do a post-transfers, and that then goes through to the payee DFSP, who can then distribute the funds. And then we get a put transfers back, which is your encrypted ILP fulfillment. So remember that that encryption mechanism that we borrow from cryptocurrencies. We get the release of the funds from the payers from the payee DFSP, and they send that back using your put transfers. We then use this patch third-party request transaction message to update the PASP and let them know that the transfer has been completed and the funds have been delivered to the end client. And on the response of that last call that you've got, that then comes back. So the third-party SDK scheme adapter then responds with the last call to say that confirmed, we've sent that message. So this is all really very technical, but essentially there's 3 calls, and those same 3 calls are the ones that you are interacting with, which is get parties. In this diagram, I've combined the 2 calls together in your implementation, you've got 3 calls. So the first one is get parties. The second one is the initiate transfer, which then triggers this part and comes back with present the challenge to the user, synchronized response. And then the last part of it is the payer signs a challenge, and then it gets back that final message to say that, yes, the transfer happened. So we are just simulating these responses, but behind the scenes, what's happening in Mojaloop is all of that detail. Are there any questions? Was that useful? Okay, so, yeah.
Okay, thank you, Paul. So my question is, most of us have already set it up to that page of seeing the monitoring and tested in Postman. But now my question is, which exact API are we supposed to hit in our solutions? Because you find we have the initiation API, we have the one for lookup, and the one for discovery. Now, which exact API are we supposed to connect to make sure that Mojaloop is interacting with our solutions?
So that sandbox that I gave you on the first day, that's the only thing that you need to do in the hackathon here, is you need to do those 3 calls, and those are the API. What I'm doing here is showing you what happens behind the scenes. So you need none of this knowledge to be able to integrate your software into the hackathon. What you need is these 3 calls: the account lookup, the initiate transfer, and the approval transfer. And those are the messages that we over here. These 3 calls that we got in that account lookup, that IP address, the 16060, the send transfer. These are the API calls that you need to make in your software. Did I answer your question?
Yes, somehow, but I've not yet gotten it well. So we have that set up, the way it is there on the screen. We already have that set up. Now, are we supposed to hit all those different APIs, lookup, initiation, and approval in our solutions? And how do we do that? Or setting up that is enough?
No, this is the sender, TTK. You need to make those calls in your software. So, so if we go back to this diagram, so this, in that sandbox deployment, we got 2 TTKs. We got the receiver TTK, which is a simulator to simulate all that stuff that I was telling you about now. So the way we simulating it is you make an API call to the local host 4040, and there's 3 calls you need to make. There's the get parties lookup, the initiate transfer, and then the acceptance of the transfer. So your solution needs to be making that call to that localhost 4040, and then our TTK receiver is going to simulate that response back. And so that's what you need to do in your software. What I'm showing you is this guy, the sender, the 16060, and it's doing what your software needs to do. So you need to replace it with your calls. The way I tried to demonstrate it earlier is you copy the curl commands here, and I imported that into Postman. But you need to import that into your software. you need to be making the same calls inside your software. And if you see those responses inside the monitoring screen, so for instance, we went through that earlier. I imported that call into Postman. If that is your software making the call, it would look like this in the monitoring screen. So the monitoring screen would then respond with the information as if you were making a call to Mojaloop. And that's all you need to do. That abstraction layer that we've got in the SDK that we're simulating here can work in production. So you could take that same integration that you're building right now, and you could install it against a third-party scheme adapter that's been configured with full security against a productionized environment with all the keys and secrets that are yours, that you're looking after, and we could integrate your software into a productionized system. So although this feels like a very thin simulated demonstration, because it is, it can actually, that same solution can scale into a productionized system. And then the consequence of that interaction is that full sequence diagram that I demonstrated earlier. Did I answer your question? Okay, great, thank you. Sorry, I just need to grab some sweets. I'll come and answer your question. Please ask your question. I'm just going to.
I just need you to go back to the part where you changed the currency from Ugandan shillings from euros to Ugandan shillings, and 10 to 10,000.
So you want me to show you again how to make those edits onto the synchronous response rules? Okay, great, I'll do that now. Open up the right TTK. So you've got to have your Docker Compose running with that sandbox running. And you need to go to the 6060, because that's the receiver TTK, and that is your simulator that you're going to be sending a message. The messages to. The port that you're sending the messages to is the 4040. So if we have a look at this diagram, we've got the 4040 here. That's the API that you're talking to. And then on the receiver side, we've got the 6060. It has got synchronized rules that's going to be responding back. And this is how you can edit those rules. So last time we edited the initiate transfer rule. Let's have a look at some of the others. Oh, that's actually not very interesting. Let's re-edit the initiate transfer one. So, are you following along? Did you go to the right place? So, synchronized response rules. That's this one here. And then you have a list of rules. Those rules are executed in sequence from the first one to the second one. So it looks to see if the first one's appropriate. If it isn't, then it runs the next one. If it isn't, it runs the next one. So if you understand this more and you want a more detailed response, you can create a new rule, sort of lower down or higher up. And what what happens is the API call comes on the 4040. It then starts at the top and it finds the relevant rule and then responds back with this fixed response. And what you can do then is just go into this and then edit your currency. So let's add a fee of 500 UGX, and then you need to save that rule. And then if we resend those messages, we can go back to, sorry, I caught it in time. Oh no, I didn't. So we can go back and resend the messages from that sender TTK in the same way that your software would make that call. And then we can see the response with the rules. If I go back to this, do you see that piece of information? Request params ID, that is responding. So if you want to cater the fixed response with information that you're sending. So for instance, the receive amount is got nothing to do with what you asked it to. So it's maybe a little bit silly. You could in fact update that with by sending back the original amount that you sent, and maybe you could add a little margin on top of that to make it more realistic for your simulation if you wanted to. And you can use that same syntax with the curly brackets and the dollar, and then becomes a variable in the code. So this is a sort of standard scripting language. I'm not sure which scripting engine they've got. I think they've got the Postman one, but there is another scripting engine. So I'm just not familiar with the name of the scripting engine, but you can add a value in there. Okay, great. So you gave the thumbs up, so you're happy. Are there other questions? So you're saying you're struggling to use it on Ubuntu? We do have guys using Docker Compose on Ubuntu. I think that's the trickiest part on Ubuntu. You've got to get your Docker Compose working, and then you go into the folder and you use Docker Compose up. I'm not too familiar with Ubuntu. No, I have run Docker Compose on Windows and Ubuntu, and that Docker Compose up normally works. If you've got other Docker Compose images maybe running, so I'm not sure if you're having problems. So the question is from someone online. They are struggling to run to get this working in Ubuntu. So the first part is making sure that your Docker Compose is properly installed and running. And the second one is to make sure that you got the right Docker Compose image running and you don't have other TTK images running. If you've already got TTK running, it's probably configured to use the same ports and they're going to conflict. So maybe make sure that those aren't running, and then make sure that you've got the right PISP TTK sandbox installed and cloned, and then you go into the folder first, and then you do the Docker Compose. So just these are the right steps to follow. We've run them a few times. Maybe just go back and make sure that they're running properly. Maybe I can view your questions on Slack afterwards.
when I tried to change the UGX, the currency, I sent the request, but in actual sense, it returned the same euro. Is there something which could have gone wrong?
Did you save your edits? The only thing I can think of. Yeah, after you've edited the synchronized rules, you've got to save them. If you're getting internal error, that's the problem you've got to fix. You've got to work out why you're getting that error and fix that, and then you get the right response. I think I need to come and see what's going on. So I can do that after the talk. Okay. Yeah, I don't know what's not configured right, but something's not right. So the way the TTK works is those synchronized rules are configured as configuration for the TTK. So somehow it's not reading it, or it's not saving it, or something's not right, and we just got to drill down into that and work out why that sync response rule is not correct. Okay. Are there other questions? Okay, so I think that's it for the talk, but I'll come and help you, those guys who have still got problems. Okay. Great, thank you.
Thank you so much, Paul. Once again, let us give him a round of applause. So today we are looking at MVP Phase 2. Now the facilitators are going to be looking at what you have. I'm going to call upon the facilitators led by Cleopatra to come and give you the next instructions. And kindly, you know, when something is being presented or there is a session, try to pay attention. Talking among ourselves, it's really not a good practice. Some of us are competing to be the best, and others are competing to be the worst. When you want to be successful, it's not about you having the best product. You should have discipline as well. It is very important. We have seen people who are knowledgeable, they are intelligent, but are indisciplined, and they have failed. Let us welcome Cleopatra.
Good morning, everybody. How are you today? Is the MVP working? Are you ready? Who wants to go first? So what we're going to do, we're going to call teams to the back, and you're going to present to us. Okay? Your core value preposition and the MVP. I don't want to see mock-ups. Okay? And I also don't want to see prototypes. Okay? Yeah, the MVP. Okay? Yeah. So, if you hear your team's name, come behind with your teammates, and we take it up from there. The rest, continue perfecting your documentation, the diagrams.
You know, the second day, we did interviews, team interviews. They were asking you what are your expectations and all that. And now this is the second last day of the hackathon. we are going to also do those interviews, how your experience you're going to share with us. So as you speak with your facilitators, we will also be getting some teams to go and do those interviews, so you can prepare accordingly. Thank you.
Team X Home, you're up first. Team UPE, please come to the back. The achievers, come and see us at the back. The achievers, are you around? Tax on point. Come to the back. Simbula Tugende. Please come to the back. Simbula Tugende. Team She Capital, come to the back. Safe and free. Safe and free. Please come to the back. Team Pesajet, please come to the back.
Excuse me, did anyone pick a laptop charger from this side back? Please, if you mistakenly took it, kindly bring it back. Laptop charger. HP. It's HP. Please kindly check to see that the laptop charger you have is yours. It's HP.